So we've already discussed um, some of the bigger objects in the solar system. We've talked a little bit about the sun. We've talked about planets and even some dwarf planets. But there are a lot of other objects in our solar system, and we're going to talk about a few of them. And some of the terminology, you may hear different things at different times. And so this is not an all inclusive list, but these are the ones that you definitely need to know in order to pass your test. And so the vocabulary is listed in this slide presentation. One of the things I did not mention in here that the solar system is filled with is dust. All kinds of dust, from things colliding, dust left over from the formation of the solar system and formation of the planets, dust left over from the protoplanetary disk that we mentioned, and the formation of the solar system. So that's probably one of the most prevalent uh, uh, things in our solar system. So I'm not going to spend a lot of time on that, but there is a lot, and that would be one of the smaller objects in our solar system. So let's get started. Let's first talk about, excuse me, let's talk about moons. So a moon, uh, not just our moon, but a moon in general, is a natural satellite that orbits an object other than a star. So as we had mentioned yesterday in playing our game, is it a planet? Um, if an object is not orbiting the sun, then it is not considered a planet. That was rule number one of the definition of a planet. And so there are some pretty decent sized objects that are orbiting other objects. They're orbiting planets, they're orbiting dwarf planets, they're orbiting asteroids, even. So, moon is a there are a few hundred moons in our solar system. So the word moon actually comes from the Greek word mene, and it literally means months. So we know that one of the ways that time was kept track of was uh, the phases of the moon, and so the moon actually comes from the Greek word for month. And so, just to give you an idea of some of the different moons in our solar system and their sizes, um, here is Earth, and here's our moon up in the top left there, and some of the moons of the other planets. Mars has very small moons, whereas Jupiter has very many, Saturn has very many, and Jupiter has four very large moons. Saturn has one very large moon and some numerous small moons, Titan being the largest. But Ganymede, Callisto, and Titan are the largest of all of the moons in the solar system. So, like I said, there are a few hundred. I don't expect you to know all of them. I just want you to have a good understanding of what a moon is when we talk about it. Now, they were referred to previously as just satellites. But once we started launching artificial satellites into orbit, that word kind of fell out of use, and we just started referring to them generically as moons after our moon. The next object is an asteroid. An asteroid is a small rocky object that orbits the sun. Um, got a little typo here. We'll fix that. There we go. A small rocky object that orbits the sun. Now, the word asteroid actually comes from a couple different Greek words, but the Greek word that we use is asteroides, which means star-like or star-shaped, and it's from the word aster, meaning star, and eidos, meaning form or kind. So whenever you see oid at the end of a word, like you'll see it in math, you'll see it in science a lot, it comes from this Greek word eidos, so meaning form or kind. So um, asteroid or Asteroides, or Asteroides, is star-like or star-shaped. It's in the form of a star. So it's a small rocky object. So it's a little bit smaller than a dwarf planet. Now, the sizes of asteroids all over the place. The shapes are all over the place. Some of them can actually be closer to round, but not quite. So once they get kind of that round shape, though they have significant mass. If you remember, we talked about hydrostatic equilibrium. So it has enough mass, has enough angular momentum to get that round shape. Ceres, which is now a dwarf, considered a dwarf planet, was actually thought to be originally a planet and then an asteroid, and then now since 2006 has been classified as a dwarf planet. So here are some of the major asteroids. And now asteroids are pretty numerous in our solar system. In fact, there is a belt of asteroids in our solar system between the orbits of Mars and Jupiter. So there's this entire area that's just filled with asteroids. And then there are some around the orbit of Jupiter as well. And these are called Trojans, I believe. And they're considered part of the asteroid belt, but they're a little bit further out near the orbit of Jupiter. And now there are asteroids that are not within the belt, but where you're going to find most of them, and these are mostly made of heavier elements. They're very rocky. These are going to be within the asteroid belt. The next object is a comet, and we're probably very familiar with these. These are small, rocky, but they're icy objects that orbit the sun. We have probably heard of quite a few of these in the past. Some of the more familiar ones are Halley's Comet. We've talked about Hale-Bopp in the past. We've talked about Neowise is a comet. These are very distinctive looking. And the word comet comes from the Greek word kometes. And it literally means wearing hair long. So having long hair. And we know this just from the way that comets look, why it has this name. Here's a time lapse of the Neowise comet that I believe was visible earlier this year. And you can see the tail of the comet flowing out away from it. That's where it gets the name kometes, wearing hair long. And comets actually have two tails. So as it comes near the sun's heat is basically vaporizing the ice that makes up the comet, and so you have the gas from the ice forming a tail, and then you have any of the other particles that are more metallic or minerals moving off in a dust tail as well. And so you can see how that works as it gets near the sun. Now, a few years back, they actually landed a probe onto a comet, and this is actual video taken from this probe, put into a GIF, but this is what it looks like on a comet. I remember hearing about this on the news. Absolutely mind-blowing. The physics and math that went into this landing onto an object moving at those speeds, and to get footage like this, just astounding. So then the next object is well, we're actually going to look at a few different ones, but your vocabulary words are meteoroid, a small rocky particle that moves through space, and meteoroid, I'm sorry, a small rocky particle that moves through space, and then meteorite, or meteor, a meteoroid that has entered into Earth's atmosphere and it produces a streak of light. So a shooting star is actually a meteor. Sometimes they're comets, but most of the time it's a meteor. And then after it hits the ground, it becomes a meteorite. So let's look at the origin of the term meteor. It comes from the Greek word meteoron, uh, and literally means a thing in the air, something in the air. Now, meteoroid, remember back eidos, a form. So a meteoroid would be a form of something in the air. Now, here is a picture of a meteor. So very similar to asteroid, but smaller. So you think you have planet being the biggest rocky object, dwarf planet being a little bit smaller, asteroid being a little bit smaller than that, and meteoroid being a little smaller than that before it becomes just dust. So again, just with asteroids and even dwarf planets, they can come in a lot of different, I'm sorry, with moons, they can come in a lot of different shapes. So you can actually see there's a couple different ones there. Now, here's a GIF of a meteor shower. These happen a few times a year. Very fascinating to see. I've been able to see them a few different times. Standing out in the mountains in the middle of the night and able to just view this. It's marvelous to see. Sometimes you'll see just maybe one or two, but then we have these showers where a number of them are coming into Earth's atmosphere, becoming meteors. Most of them don't strike the ground, they burn up in the atmosphere. Now, outside of the orbit of Neptune, we have what's known as the Kuiper Belt. And the Kuiper Belt, it is an area where, in fact, where Pluto's orbit is, and it's filled with objects very similar to the asteroid belt, but the objects in the Kuiper Belt are not just rocky; they're also made of ice. So think of the asteroids, but icy asteroids in a belt-like area outside of Neptune. And so it's filled with these objects. Some of them are called Plutoids. There's a lot of different names for them, but they refer to them as KBOs for Kuiper Belt objects. So you see that there. But then we have kind of this hypothetical area outside of the Kuiper Belt. Now, the Kuiper Belt would still be in a flat, um, uh, close to the same plane as the orbits of the planets, because if you remember, as the protoplanetary disk was forming, it flattened out. But then we have this like hypothetical area called the Oort cloud. And this would actually be more spherical, but it's thought to surround the entire solar system. And it's thought to be made up of what are called cometary nuclei. So they propose that this is where most comets come from. So as the galaxy sends off what's called a galactic tide, energy pulses and solar waves and things like that, gravitation shifts, it would cause an object, a cometary nuclei, to move towards the sun. This is a comet now, and as it loops around the sun, it comes back into the Oort cloud, and it's it's supposed to be made of billions of comets. So these are the main objects that you're going to find other than the sun and planets and dwarf planets in our solar system.